The war in Ukraine has become a vast and complex battlefield. It is a conflict defined not by a single weapon, but by an ever-changing arsenal. From the humble trenches dug by determined soldiers to the sophisticated satellites orbiting high above, every piece of technology plays a role. Artillery duels echo across the sprawling front lines, where old Soviet-era cannons fire alongside modern Western howitzers. Tanks, both ancient and new, clash in the muddy fields of the Donbass, while infantry fight house to house with rifles and grenades. This is a war of immense scale, a brutal contest of attrition that consumes vast quantities of ammunition, vehicles, and, most tragically, human lives. Over the years of this full-scale invasion, the character of the fighting has evolved dramatically. What began with rapid Russian advances toward Kiev has settled into a grinding war of position. The front lines, stretching over 1,000 kilometers, have become a deadly landscape of minefields, fortifications, and constant surveillance. In this environment, the ability to see and strike deep behind enemy lines is paramount. Both sides have deployed a dizzying array of tools to achieve this, from long-range missiles and reconnaissance drones to sabotage groups operating in the shadows. The struggle for technological superiority is as fierce as the fighting on the ground, with each side constantly seeking an edge over the other. Among the countless weapon systems deployed, a few have stood out as true game-changers, fundamentally altering the dynamics of the conflict for a time. Early in the war, Turkish-made Bayraktar TB2 drones gave Ukraine a crucial advantage, striking Russian columns when the invaders least expected it. Later, the arrival of Western anti-tank missiles like the Javelin and NLAW helped halt the initial armored onslaught. Each new piece of equipment forces adaptation, a deadly dance of innovation and counter-innovation. The war has become a relentless cycle of problem and solution, where survival depends on the ability to learn, adapt, and overcome the challenges posed by the enemy. This constant evolution is the central story of the war's military dimension. No single weapon remains dominant for long. An advantage gained today might be neutralized by a new tactic or technology tomorrow. This pattern was perfectly illustrated by the introduction of a powerful American rocket system. For a period, it seemed to give Ukrainian forces an almost magical ability to strike at the heart of the Russian war machine. It was called the M142 High Mobility Artillery Rocket System, or HIMARS. Its arrival marked a pivotal moment, demonstrating how one key capability could reshape the entire battlefield and offer a glimpse of victory. The M142 HIMARS is not just another piece of artillery, it's a highly advanced, precision-guided weapon system that combines mobility, range, and incredible accuracy. Mounted on the back of a medium-sized military truck, the system is designed to be fast and elusive. Its core principle is often described as shoot and scoot. A HIMARS crew can drive to a concealed firing position, launch its rockets at a target many dozens of kilometers away, and then immediately drive off to a new location. This entire sequence can be completed in a matter of minutes, making it exceptionally difficult for the enemy to locate the launcher and fire back. It's a modern incarnation of guerrilla warfare, fought with 21st-century rockets. What makes the HIMARS so deadly is not just its mobility, but the munitions it fires. The standard rocket used by Ukraine is the Guided Multiple Launch Rocket System, or GMLRS missile. Each rocket is guided by GPS, allowing it to strike targets with pinpoint accuracy, often within a few meters of the designated coordinates. A single launcher carries a pod of 6 of these rockets, which can be fired individually at separate targets or all at once to devastate a larger area. This precision means that instead of leveling an entire city block to destroy one building, as is common with older, unguided rockets, a HIMARS can surgically remove a single high-value target while minimizing collateral damage. Developed by the United States in the late 1990s, the HIMARS was designed to provide the Army with a responsive, all-weather, long-range fire support system. It filled a critical gap between traditional cannon artillery, which has a shorter range, and more strategic assets like cruise missiles or aircraft, which are more expensive and complex to deploy. The system's relative simplicity, and its integration onto a standard truck chassis, make it easier to maintain and operate in harsh battlefield conditions. For Ukraine, receiving a weapon that was both incredibly effective and robust enough for the rigors of a high-intensity war was a monumental development, promising to change the fundamental arithmetic of the conflict. When the first HIMARS systems arrived in Ukraine in the summer of 2022, they were greeted as a symbol of hope. Soldiers on the front lines, who had been outgunned by Russia's vast artillery parks, finally had a tool that could reach out and touch the enemy's most critical assets far behind the front. The system's reputation preceded it, and it was quickly nicknamed the God of War by Ukrainian troops. This was more than just a new weapon. It was a powerful message that Ukraine's partners were providing the tools needed not just to defend, but to start pushing the invaders back. The era of HIMARS had begun, and the Russian military was about to feel its full, devastating impact. The introduction of HIMARS into the Ukrainian arsenal in mid-2022 had an immediate and profound impact on the battlefield. Russian forces, which had relied on a strategy of overwhelming firepower from massed artillery, suddenly found their logistical backbone under constant threat. Ukrainian operators began using the system's range and precision to systematically hunt and destroy high-value Russian targets deep in occupied territory. Ammunition depots, fuel dumps, command headquarters and bridges all became vulnerable. For the first time, Ukraine could consistently disrupt the flow of supplies and orders to Russian frontline units, causing chaos and crippling their ability to sustain offensive operations. The effect was nothing short of revolutionary. One of the most visible signs of HIMARS's effectiveness was the series of massive explosions that lit up the night sky across occupied Ukraine. A Russian military blogger lamented in late 2023 that the second half of 2022 was a time of large fireworks at the front, a direct reference to the spectacular destruction of Russian supply depots by GMLRS rockets. These strikes were not random. They were the result of careful intelligence gathering, often using a combination of satellite imagery, drone reconnaissance, and information from partisans on the ground. A single successful strike could destroy thousands of artillery shells, leaving Russian batteries starved of ammunition and unable to support their troops. This degradation of Russian logistics was a key factor in Ukraine's successful counteroffensives in late 2022, particularly in the Kharkiv region. With their supply lines severed and their command centers in disarray, Russian frontline troops were left isolated and vulnerable. This allowed Ukrainian forces to execute swift, decisive maneuvers that shattered the Russian lines and liberated thousands of square kilometers of territory. Similarly, in the south, HIMARS strikes on key bridges across the Dnipro River made it nearly impossible for Russia to resupply its garrison in the city of Kherson, ultimately forcing a humiliating withdrawal. The weapon was not just destroying targets, it was enabling strategic victories. The psychological impact on Russian troops was just as significant as the physical destruction. The constant threat of a sudden, precise, and unavoidable strike created an atmosphere of fear and paranoia. Russian commanders were forced to constantly relocate their headquarters, and their Pegbird and supply depots had to be dispersed into smaller, less efficient caches. This disruption slowed the entire Russian war machine down, forcing it to adapt in ways that made it less effective. The HIMARS became a phantom menace, a symbol of Ukrainian power that could strike anywhere, at any time. It demonstrated that superior technology, when wielded with skill and courage, could overcome a numerically superior foe. No military advantage lasts forever, and the era of HIMARS dominance was no exception. The Russian military, after suffering devastating losses throughout late 2022 and early 2023, began a concerted effort to counter the American-made rocket system. Their primary solution came from the field of electronic warfare, or EW. Russian engineers worked tirelessly to develop and deploy sophisticated jamming systems designed to interfere with the GPS signals that guide the GMLRS rockets to their targets. Reports from the front lines in May 2023 indicated that these new EW tactics were starting to work, causing HIMARS rockets to veer off course and miss their intended targets. The Russian adaptation process was methodical and relentless. It is believed that Russian specialists managed to obtain and reverse engineer fragments of GMLRS rockets that had been shot down or had malfunctioned. By studying the components, they were able to identify the specific frequencies used by the GPS guidance systems and develop jammers tailored to disrupt them. This technological cat-and-mouse game began to tip in Russia's favor. By late 2024, some analysts, cited in reports by The Atlantic, estimated that the effectiveness of HIMARS had been drastically reduced, perhaps to as low as 10% in areas with heavy Russian EW coverage. The wonder weapon was becoming less wonderful. Alongside electronic countermeasures, Russia also intensified its efforts to hunt and destroy the HIMARS launchers themselves. Drones, spies, and satellite surveillance were all focused on finding the elusive trucks before they could fire and scoot. While Ukraine became extremely proficient at concealing the systems, the sheer volume of Russian reconnaissance assets meant that some were eventually found. By the end of 2024, Russia claimed to have destroyed or damaged over 30 launchers, and while Ukraine officially acknowledged far fewer losses, the threat was real. Each potential loss made Ukrainian commanders more cautious about deploying their most prized assets, further limiting their use. A final, critical factor in the declining use of HIMARS was the simple issue of supply. Each GMLRS rocket is an expensive, high-tech piece of ordnance, and Ukraine's stockpile was finite. The flow of Western military aid, particularly from the United States, slowed significantly during 2025. By July of that year, one military expert, Thomas Theiner, warned that Ukraine's GMLRS ammunition would only last until September with cautious use. This forced Ukrainian forces to conserve their precious rockets, reserving them for only the most critical, high-priority targets. The days of nightly fireworks were over. The once mighty HIMARS, blunted by Russian EW and constrained by dwindling supplies, was no longer the all-powerful battlefield solution it once had been. Faced with the diminishing effectiveness of HIMARS and a shortage of Western munitions, Ukraine did not despair. Instead, it turned to its greatest strength, the ingenuity and fierce determination of its people. The Ukrainian defense industry, alongside a vibrant ecosystem of private engineers and volunteers, embarked on an ambitious new project. If they could no longer rely on imported rockets to strike deep behind Russian lines, they would build their own solution. This imperative gave birth to a new class of weapon domestically produced medium-range attack drones, designed specifically to fill the capability gap left by the hampered HIMARS. This was not simply about building more of the small, short-range FPV drones that had already become ubiquitous on the front lines. This new initiative focused on creating a different kind of unmanned aerial vehicle. These drones were designed to operate at ranges similar to HIMARS, from a few dozen to a few hundred kilometers. Their mission was to hunt the same types of targets: camouflaged command posts, dispersed logistics hubs, and, crucially, the very Russian electronic warfare systems that were jamming the GMLRS rockets. They represented a strategic pivot, moving from reliance on a foreign system to self-sufficiency in a key area of warfare. The development of these drones presented unique and formidable challenges. Unlike long-range strategic drones that can be guided by satellite GPS to a fixed coordinate, these medium-range attackers needed to hunt for mobile or well-hidden targets. This requires a live, continuous data link between the drone and its operator, allowing them to see what the drone sees and guide it to its target in real time. Maintaining a stable and secure connection over such long distances, in an environment saturated with Russian jamming, is an immense technical hurdle. It required Ukrainian engineers to develop innovative communication technologies and anti-jamming techniques from scratch. This drive for innovation is a defining characteristic of Ukraine's war effort. From modifying non-Sondrin, modifying the Stubbermarsch, flying commercial drones to carry grenades to developing sophisticated sea drones that have crippled Russia's Black Sea Fleet, Ukrainians have repeatedly demonstrated an extraordinary ability to adapt and create. The development of medium-range attack drones is the latest chapter in this story. It is a direct response to a specific battlefield problem, born out of necessity. As the flow of Western aid became less certain, the message was clear. Ukraine had to find its own way to sustain the fight. These new drones are the tangible result of that realization. The new Ukrainian drones and the HIMARS system are designed to achieve a similar goal, striking valuable targets behind the front lines, but they do so in fundamentally different ways. The HIMARS is a weapon of overwhelming force and speed. Its GMLRS rocket travels at supersonic speeds, arriving on target with little to no warning. It delivers a powerful high-explosive warhead that can obliterate a building or a vehicle in a fraction of a second. The strength of HIMARS lies in this sheer destructive power and the shock of its sudden arrival. It is the perfect tool for destroying a known stationary target like a major ammunition depot or a headquarters building whose location has been confirmed by intelligence. In contrast, the new medium-range drones operate on a principle of persistence and precision search. Instead of a high-speed projectile, the drone is a flying camera with an explosive payload. It is much slower than a rocket, loitering over the battlefield for an extended period. This allows the operator, who may be sitting safely many kilometers away, to act as a hunter. The operator can use the drone's high-resolution camera to scan the ground, search for camouflage targets, and positively identify an enemy position before committing to an attack. This man-in-the-loop capability is a crucial advantage when targets are mobile or hidden, something a GPS-guided rocket cannot do. This difference in operation makes the drones particularly well-suited for the modern, adapted battlefield. After the initial HIMARS shock, the Russian military learned to disperse its forces. Large headquarters were broken up into smaller mobile command posts. Ammunition was no longer stored in massive depots, but scattered across numerous smaller sites. These dispersed targets are much harder to find, and are less suitable for a costly GMLRS rocket. A drone, however, can patiently search a suspected area, follow a supply truck to its hidden drop-off point, or spot the antennas of a mobile EW system poking through the trees, allowing for a precise strike on a target that intelligence might otherwise have missed. Perhaps the most significant difference is cost. A single GMLRS rocket costs hundreds of thousands of dollars. An entire salvo of 6 rockets represents a multi-million-dollar investment. In contrast, while not cheap, the new medium-range attack drones can be produced for a fraction of that cost. This economic reality is transformative. It allows Ukraine to take risks and hunt for targets in a way that would be unsustainable with HIMARS rockets. An operator can afford to send a drone on a search mission that might yield nothing. This cost-effectiveness enables a higher volume of deep strikes, putting relentless pressure on Russian forces, even with a much smaller budget. When comparing the new Ukrainian drones to the established HIMARS system, it is clear that each has a distinct set of advantages and challenges. The primary advantage of HIMARS remains its speed and survivability against traditional air defenses. A GMLRS rocket is extremely difficult to shoot down due to its high velocity and small size. Its shoot-and-scoot launcher is also a highly survivable platform. As long as it can evade Russian jamming, HIMARS offers a near-guaranteed strike on a known target. Furthermore, its powerful warhead ensures a high probability of destroying even hardened targets. It is a reliable and powerful sledgehammer, perfect for smashing static, high-value objectives. The drones, however, offer unparalleled flexibility and affordability. Their main advantage is the ability to perform reconnaissance and attack in a single mission. The operator can locate, identify, and confirm a target in real time, reducing the risk of hitting the wrong thing or wasting a strike on a decoy. This is invaluable against an enemy that has learned to camouflage and disperse its assets. The low cost of these drones means they can be used in far greater numbers, creating a persistent threat across a wide area of the front. They can be tasked with hunting down and destroying the very Russian EW systems that threaten HIMARS, creating a symbiotic relationship where the drones can help clear a path for the rockets. However, these drones are not without their own vulnerabilities. Being much slower than a rocket, they are more susceptible to being shot down by conventional anti-aircraft guns and missiles. Their reliance on a continuous live data link for control also presents a significant challenge. This link is itself a target for Russian jamming. If the connection is severed, the drone can be lost or rendered ineffective. Developing robust and encrypted communication links that can resist sophisticated enemy EW is the single greatest technical hurdle for Ukraine's drone engineers. The success of this new drone fleet will largely depend on their ability to win this invisible battle of the airwaves. Ultimately, the drones are not a perfect replacement for HIMARS, but a crucial complement to it. In an ideal scenario, Ukraine would have an abundant supply of both. The drones could serve as the hunters, finding and fixing enemy positions, while the HIMARS could act as the killer, delivering a swift and devastating blow once a target is confirmed. For example, a drone could identify a Russian S-400 air defense battery, and a HIMARS could then fire a rocket to destroy it. In the current reality of limited HIMARS ammunition, however, the drones have become the primary tool for maintaining pressure on the Russian rear. They are Ukraine's innovative and cost-effective solution to a pressing battlefield problem. The story of Ukraine's pivot from relying on HIMARS to developing its own medium-range drones is more than just a tale of military hardware. It is a powerful illustration of the nation's defining spirit of resilience and ingenuity. When faced with a seemingly insurmountable challenge, the neutralization of their most effective weapon and dwindling foreign supplies, the Ukrainian people did not surrender to fate. Instead, they innovated. They harnessed their domestic talent, from state-owned defense firms to grassroots engineering collectives, to create a new solution tailored to the specific needs of the evolving battlefield. This ability to adapt and build is Ukraine's most vital strategic asset. This homegrown innovation carries immense strategic importance. It reduces Ukraine's dependency on the often fluctuating political will and industrial capacity of its international partners. As the war grinds on, the ability to produce effective weapons domestically ensures that the Ukrainian armed forces can sustain their fight, regardless of delays or reductions in foreign aid. It sends a clear message to Moscow that this is not a war that can be won simply by waiting for the West to lose interest. Ukraine is building the capacity to defend itself for the long term, creating a sovereign defense industry forged in the fires of conflict. Every drone built in a Ukrainian workshop is a testament to this self-reliance. The development of these drones showcases a model of modern warfare where agility and cleverness can rival brute force. Russia continues to rely on mass, throwing vast quantities of older equipment and poorly trained troops into the fight. Ukraine, by necessity, must fight smarter. It leverages technology to create an asymmetric advantage, turning cheaper, more flexible systems into giant killers. This approach, seen in its anti-ship sea drones, and now its medium-range attack UAVs, allows Ukraine to impose disproportionate costs on the larger Russian military, disrupting its operations and degrading its morale in a sustainable way. It is a 21st-century David versus Goliath story, played out with circuits and software. Ultimately, the drones, like the HIMARS before them, are tools. Their true power comes from the hands and hearts of the people who wield them. They represent the unbreakable will of a nation fighting for its very existence. The creativity that turns a workshop into a drone factory is the same spirit that drives a soldier to hold the line in a trench. It is a spirit of defiance that refuses to be broken. As this brutal war continues, it is this relentless innovation and the unyielding resilience of the Ukrainian people that will, more than any single weapon system, determine the final outcome and secure the future of a free and independent Ukraine.